Hi everyone, welcome back to my channel SciZap. So this is another video in the series to understand data partitioning. Not data partitioning, another video to understand systems design, and today we will be talking about data partitioning. Before I begin, please don't forget to like, subscribe, and share my videos, and leave a comment if you like what I am producing. And if you want to listen to different kinds of content that you think might be useful for you, please leave a comment below and I will respond with a video of your choice. So let's start with data partitioning. So data partitioning is a technique to break up a big database into smaller parts. It is the process of splitting up a database or table across multiple machines to improve the manageability, performance, availability, and load balancing of applications. So you will see throughout the entire distributed systems and AWS series, these will become your most used and most favorite words. So the justification for data partitioning is that after a certain scale point, it is cheaper and more feasible to scale horizontally by adding more machines than to grow it vertically by adding more servers. So now there are two kinds of data partitioning available. Three, in fact, my apologies. So there is horizontal partitioning, vertical partitioning, directory-based partitioning. So let's discuss what horizontal partitioning is. So in this partitioning scheme, we put together rows into different tables. So for example, if you are sorting different places in a table, we can decide that the locations with zip codes less than 1,000 are stored in one table, and the places with zip codes greater than 1,000 are stored in a separate table. So this is also called a range-based partitioning, as we are storing different ranges of data in separate tables. Then horizontal partitioning is also called data sharding. So you're horizontally partitioning depending on the ranges that you set. So the key problem with this approach is that if the value whose range is used for partitioning isn't chosen carefully, then the partitioning scheme will lead to unbalanced servers. So if the previous example that I gave, splitting location based on their zip codes, assumes that places will be evenly distributed across different zip codes. So this assumption is not valid, as there will be a lot of places in a thickly populated area, such as Manhattan or New York, compared to other suburban cities. So if you have, say, more zip codes less than 1,000, that shard will be weighed more than the one where you don't have too many zip codes that's less than 1,000. So it will be uneven balance. Then you have vertical partitioning. In this scheme, we divide our data to store tables related to specific feature in their own server. For example, we are building Instagram-like application where we need to store data related to users, photos they upload, and people they follow. So we can decide to place user profile information on the database server, friend lists on another, and photos on a third server. But vertical partitioning is straightforward to implement and has a low impact on the application. But the main problem with this approach is that if your application experiences additional growth, then it may be necessary to further partition a feature-specific database across various servers. For example, it would be possible for a single server to handle all of the metadata queries for 10 billion photos by 140 million users. Third is directory-based partitioning, a loosely coupled approach to work around issues mentioned in vertical and horizontal partitioning schemes is to create a lookup service which knows your current partitioning scheme and abstracts it away from the database access code. So to find out where a particular data entry resides, we query the directory server that holds the mapping between each tuple key to its database server. So this loosely coupled approach means we can perform tasks like adding servers to the database pool or changing your partitioning scheme without having an impact on the application. Now, there are some criteria that you can follow when you partition, and now we will discuss at least 4 of the partitioning criteria. So there is a key or hash-based partitioning. So under this scheme, you can apply a hash function to some key attributes of the entity you're storing, and that yields a partition number. So for example, if you have 100 database servers and your ID is a numeric value that gets incremented by 1 each time a new record is inserted. So in this example, the hash function could be ID percentage 100, which will give us the server number where we can store, read that record. This approach should ensure a uniform allocation of data among servers. So the fundamental problem with hash-based partitioning is that it effectively fixes the total number of database servers, since adding new servers means changing the hash function every time, which would require redistribution of the data and downtime for the service. So a workaround for this problem to use consistent hashing. Now, what is consistent hashing? We will talk about in some time. Now let's talk about list partitioning. So in this scheme, each partition is assigned a list of values. So whenever you want to insert a new record, you will see which partition contains the key and then store it there. So for example, we can decide for all users living in Iceland, Norway, Sweden, Finland, or Denmark will be stored in a partition for the Nordic countries. Then the third is round-robin partitioning. This is a very simple strategy that ensures uniform data distribution. With n partitions, the I tuple is assigned to partition, which is I mod n. Now, the fourth one is composite partitioning. So under this scheme, we combine any of the above partitioning schemes to devise a new scheme. For example, first applying a list partitioning scheme and then a hash-based partitioning. So consistent hashing could be considered a composite of hash and list partitioning, where the hash reduces the key space to size that can be listed. Now, there are some problems with data partitioning. So on a partition database, there are some extra constraints on the different operations that can be performed. So most of these constraints are due to the fact that operations across multiple tables or multiple rows in the same table will no longer run on the same server. So here are some constraints and additional complexities introduced by partitioning. So there are three main problems that usually systems architectures try to solve. So joins with denormalization. So performing joins on a database which is running on one server is pretty straightforward, but once a database is partitioned and spread across multiple machines, it is not feasible to perform joins that span database partitions. So such joins will not be performance efficient since data has to be compiled from multiple servers. So a common workaround for this problem is to denormalize the data so that queries that previously required joins can be performed from a single table. So the service now has to deal with all perils of denormalization, such as data inconsistency. And what is denormalization? I will discuss and dedicate a separate video to that. Second issue is referential integrity. So as we saw that performing a cross-platform query on a partition database is not feasible. Similarly, trying to enforce data integrity constraints such as foreign keys in a partition database can be extremely difficult. So most of the relational database do not support foreign keys constraints across databases on different database servers, which means that applications that require referential integrity on partition databases often have to enforce it in an application code. So often in such cases, applications have to run regular SQL jobs to clean up dangling references. The third is rebalancing. So there could be many reasons we have to change our partitioning scheme. So the data distribution is not uniform. For example, there are a lot of places for a particular zip code that cannot fit into one database partition. Second is that there is a lot of load on a partition, so there are too many requests being handled by the database partition dedicated to user photos. So in such cases, either we have to create more database partitions or have to rebalance existing partitions, which means the partitioning scheme changed and all existing data moved to new locations. So doing this without incurring downtime is difficult. It's very difficult. So using a scheme like directory-based partitioning does make rebalancing a little more palatable experience at the cost of increasing the complexity of the system and creating a new single point of failure. So in terms of this video, I think I'll conclude here. It's a lot of information to gather. So the most important that you should remember is the kinds of partitioning methods. There's horizontal, vertical, and directory-based. Now, directory-based is one that is most often used, but you should know the differences between both, all three of them. There are some criteria that you have to abide by, like this hash-based partitioning, list partitioning, round-robin, and composite partitioning. And if you want to learn more about each of these and what they are at length, then please leave a comment below and I will create a video to discuss them. Then in some of the common problems that you face with partitioning data is denormalization and joins, referential integrity, and rebalancing. So for now, that's it for this video. I hope you liked my content for today. Please don't forget to like, subscribe, and share, and I hope to see you next time. Bye.